Thousands of miles away from the well-known volcanoes of the Pacific Ring of Fire, a strange geological phenomenon is unfolding in northern Canada, beneath Hudson Bay. This region isn't exactly known for violent earthquakes or eruptions, yet it's quietly experiencing something geologists are calling deeply unsettling. The ground there is moving, and not just slowly over centuries. It's shifting rapidly, in a way that's setting off alarm bells for scientists monitoring seismic activity across the continent. Canadian and American experts are now asking a terrifying question. Could these movements beneath Hudson Bay trigger one of the most dangerous volcanoes on Earth, Yellowstone? A network of sensors around Hudson Bay, including GPS receivers and gravity meters, recently detected unusual ground movement. At first, it seemed to be part of a well-known process called post-glacial rebound, where land slowly lifts after being weighed down by ancient ice sheets. But this time the rebound isn't acting normally. The Earth is rising faster and more unevenly than scientists predicted, pointing to deep geological shifts occurring far below the surface. It's not just the pace but also the direction and intensity of the movement that's raising eyebrows in research labs. By March 2025, a joint report from Canadian and American geologists confirmed what many feared. The crust under Hudson Bay isn't just rebounding, it's realigning, and the pressure waves from this movement are traveling farther than anyone expected. These waves seem to be stirring old fault lines that were thought to be stable, even dormant. Some areas are rising by over 11 millimeters per year, which is shockingly fast by geological standards. This kind of vertical and horizontal shift could have major consequences well beyond the Hudson Bay region. Using seismic tomography, scientists discovered that the upper mantle beneath Hudson Bay is acting strangely. Zones of ductile flow, where rock behaves more like thick liquid, appear to be forming. That's not something you'd expect in a stable craton like this one. Even more concerning, the land isn't just rising. It's tilting, which could redistribute underground stress in unpredictable ways. This tilt has the potential to awaken ancient fault lines and trigger tectonic chain reactions that stretch across the North American continent. Satellite data has added another layer of mystery. Gravity mapping shows changes in mass distribution under Hudson Bay, something you wouldn't normally see happen so quickly. It suggests powerful forces are reorganizing deep beneath the surface. And this is where the Yellowstone connection begins to make sense. Both Hudson Bay and Yellowstone sit along the same massive ancient block of crust called the North American Craton. It's a billion-year-old structure that covers much of the continent, and while it's usually stable, it acts as a superhighway for seismic energy when stress builds up. Unlike fractured crust found near tectonic boundaries, the North American Craton is incredibly rigid. That means pressure and vibrations can travel through it quickly and directly, almost like sound through a steel beam. Scientists are now realizing that major changes at one end of the craton, like those happening beneath Hudson Bay, can transmit stress to the other end, including the Yellowstone region. This is more than a theoretical risk. New data suggests it may already be happening. A recent computer model from the U.S. Geological Survey and Canadian Geological Commission fed Hudson Bay's movement data into a simulation. The result? Stress paths emerged across the craton, stretching from northern Canada to the Rocky Mountains, and directly toward the Yellowstone hotspot. While it doesn't guarantee an eruption, it's a clear warning that geological stress is building in dangerous places. What shocked scientists even more was the discovery of microfractures forming along these stress lines, fractures that intersect with known volcanic plumbing systems under Yellowstone. In March 2025, low-frequency tremors were detected near Yellowstone. These aren't the sharp jolts of typical quakes. Instead, they suggest the slow movement of fluids or gases underground. Their direction and location match the stress patterns flowing from Hudson Bay. At the same time, researchers noticed a slight increase in helium-3 gas levels in samples taken from Yellowstone's fumaroles. Helium-3 is a rare gas that usually comes from deep inside the Earth, another potential sign that magma could be rising closer to the surface. The signs kept adding up. Satellite thermal imagery showed new hot spots forming near the Norris Geyser Basin, areas that weren't hot just months earlier. At the same time, tilt meters recorded subtle elevation changes on the western side of the Yellowstone caldera. Put together, these indicators suggest pressure is slowly building beneath one of the most volatile volcanic systems in the world. No single sign is conclusive on its own, but in combination they tell a story that's difficult to ignore. Within U.S. and Canadian government agencies, there's a growing sense of urgency. Emergency meetings have been held, involving FEMA, the Department of the Interior, and the Canadian Geological Service. Although the public is being told there's nothing to worry about behind closed doors, contingency plans are being reviewed and quietly activated. Special response teams have been mobilized, and new drills are being run to prepare for a possible volcanic or seismic crisis in the months ahead. Equipment is being quietly moved into position: portable air filtration units, ash protection masks, and backup communication systems. FEMA has even started new contracts to acquire volcanic ash cleanup machinery, despite there being no recent eruptions. Cybersecurity teams have joined in too, preparing for scenarios where ash clouds knock out communications or power grids. One joint exercise is operating under the code name Operation Basalt Veil, a chilling hint at the level of seriousness behind the scenes. In parallel with all this, scientists are working with indigenous communities who have passed down ancient stories of Earth changes. These oral traditions, often dismissed by earlier researchers, are now proving surprisingly accurate. Some indigenous elders recall stories of trembling ground, moaning earth, and strange sky colors, events that now resemble descriptions of glacial collapse or volcanic precursors. By comparing these stories with modern seismic and atmospheric data, researchers are uncovering correlations that could help forecast future activity. These cultural records may even offer insight into rare but recurring events that modern science doesn't fully understand. In one example, elders from Manitoba described strange sounds and sudden animal migrations shortly before a 2019 ice fracture, an event that was later confirmed by satellite and seismic instruments. Such knowledge, long overlooked, is now being taken seriously by geologists trying to understand the current shifts. Back to the big question: could the ancient North American craton actually break under the pressure it's now experiencing? Scientists don't expect the continent to split apart, but they are worried about deep cracks forming. These fissures wouldn't be dramatic at the surface but could open up hidden pathways for magma to rise. That's a process called magmatic underplating, and once it starts, it can silently build massive underground magma chambers. These chambers, if they continue to grow, could slowly reshape the Earth's crust in ways that increase the risk of volcanic activity. They also change how seismic energy travels, which could further destabilize regions like Yellowstone. Cracks forming in the craton could even reactivate long-dead fault lines and open new pathways for heat and gas to escape. The process would be slow, but its consequences could unfold in ways that dramatically reshape North America's geological future. Adding another layer to the mystery, researchers have detected subtle changes in Earth's magnetic field around both Hudson Bay and Yellowstone. Tiny shifts in local magnetism, measured in nanoteslas, were picked up by satellites and ground sensors at the same time crustal changes were recorded. Some scientists think these magnetic anomalies could be tied to rising magma or changes in electrical conductivity deep underground. If true, they might offer a new way to monitor geological unrest. In early 2025, both ground sensors and satellites recorded magnetic pulses that corresponded with tremors in Manitoba and Wyoming. Missions like NASA's geomagnetic satellites and the European Space Agency's Swarm constellation confirmed the signals. These findings are still being analyzed, but early results suggest Earth's magnetic behavior could serve as an early warning tool, possibly even before seismic waves or gas emissions reveal trouble. Zooming out, some experts believe what we're seeing now isn't just a Canadian or American event, it's part of a larger global pattern. Around the world, volcanoes are waking up, and earthquakes are appearing in unusual places. There's growing evidence that Earth may be entering a new period of crustal instability, where stress built up over centuries is finally releasing across multiple systems. From Iceland to the East African Rift, from Japan to Central Asia, seismic activity is rising. Satellite data shows that strain isn't just occurring at plate boundaries, it's happening deep within continental interiors as well. Places that haven't shifted in decades are starting to tremble. Scientists are scrambling to understand whether this is a short-term coincidence, or a long-term shift in how our planet behaves. If the latter is true, Yellowstone might not just be a national concern, it could be one part of a much bigger story unfolding beneath our feet.